Hello guys, welcome back to my channel, Memo African Motives. Still working on engineering science and 2. So in this platform we shall be working on the question paper which was actually written in August 2021. That is work, power and efficiency. That is the part that we shall be focusing on. So that is what you're going to have from this platform, from the question paper which was written in August 2021. So if you're new guys, you can consider subscribing so that you become part of the family, so that you'll be having more classes as we shall be moving on as a family Memo African Motives. Okay, so without wasting much of your time, let us quickly rush through the question paper that I'm having here. So the first part we are asked on 4.1, which is on question 4.1, define energy. That is the first question that we are given, to define energy. So how can we define energy? We know that this is the ability to do work. That is, the energy is the ability to do work, and this energy is measured in joules. So it's not all about the definition. Also, you can even state the units of measurement. All right, so this one is measured in energy. There are so many types of energy that we can have. All right, so on 4.2 we are given that a crane hoists a load of 5,000 Newton to the top of a building 30 meters high. The chain used to hoist the load has a weight of 20 Newton per meter. So take note, it is a weight of 20 Newton per meter there. Calculate the total work done in hoisting the load and the chain. Calculate the total work done. All right, looking at the question that you are given, we can at least take down some information there, which is we are given the weight here. Okay, first at which is 20 Newton per meter. All right, so with the information that we are given, guys, it's best for you to actually have a diagram. Yes, they didn't ask you to draw the diagram, but it is best for you because you know that total work done is simply equivalent to the area under the graph. So having a diagram, guys, is something that is gonna be nicer for us. So this is force diagram that we shall have, FD. So we know, guys, this one we are now used to it, how it's supposed to look like. So remember, that is where we are going to have our force here, which is measured in newtons, and here we'll be having our distance. All right, so we know that from the start here we are given that it's hoisting a load of 5,000 to the top of the building 30 meters high. All right, so this is going to be 5,000. So let's just say this is our force, where we've got 5,000 newtons in this case. So from this 5,000 you're going to move a distance of 20. So let's just, this is just a sketch, guys, don't worry about this. We just say something like this. All right, so definitely I'm gonna take this down, or let me just put it here. It's even fine even at this point. Okay, so here I'm just going to put dotted lines to indicate my distance. So the distance is this one, 30 meters high. All right, so this is my 30 here. All right, so at least having a sketch can help you guys to answer this question in an easier way. So take note, we've got the weight of 20 Newton per meter and we've got 30 meters, so we're going to multiply to calculate the actual value of the weight, which is 20 Newton per meter times the distance that we are given, which is 30. So if we multiply 20 times 30, that is going to give us 600 newtons. All right, we know that this 600 is the one that we are going to add to 5,000. So we're going to add 600 plus 5,000, so that we are going to obtain 5,600. So you add 600 to 5,000. So now you can join your diagram. Remember, guys, how you're supposed to draw this diagram. All right, so now it's easier for us to calculate what we want in this case, since we need the total work done. So we've got two shapes that you've created, a rectangle and a triangle. So this is where we are going to have our total work done. So that is what we are having, guys, in this case here. You can just write even WD, like total work done is equivalent to the area under the graph. All right, so this one is equivalent to area under the graph. So which area are we talking about? We've got area of a rectangle, which is base times height, base times length here, sorry, times the breadth, sorry for that. And we've got half BH for the triangle. Take note, guys, a rectangle, you've got the length and the breadth, so you're going to multiply 5,030. This is what you're talking about here. From this point to this point is 5,000, from this point to this point is 30. So it's going to be length times breadth, which is 5,000 times 30. Okay, we add to the one of a triangle, which is half times the base. According to this triangle, this is the base from this point up to this point, okay, which is 30. Multiply by the perpendicular height. So this is the height of the triangle here, which is the difference between these two, because here it's 5,000, here it's 5,600. So 5,600 minus 5,000, which is that difference of 600 that we had here. So that is what you're going to have there. It is easier when you've got a diagram, as you can see. Now you can just combine your values, which is going to give you 150,000 plus these two. If you multiply them, you're going to obtain 9,000 from these two. So this is going to be 9,000. Then we can add to combine this, which is going to give us 159,000 joules. So take note, this is work done, which is measured in joules. So you can leave your answer like this, or you can convert this to kilojoules, because we've got 3 here. Remember, 3 zeros represent kilo, so it can be kilojoules like that. If it was 6 zeros, it was going to be mega joules like that, but this one is 3, it's going to be kilo. So that is the total work done. Now on 4.22, we are now calculate the total power required in hoisting the load and the chain if it takes 5 minutes to hoist the total load. So we are given the time for this to happen, 5 minutes. It takes 5 minutes. All right, so we have a relationship between the work done and the time. We know that we've got a relationship, a strong relationship between these two. What is this relationship? We know that the power is equivalent to the work done over the time, but this time should be in seconds. So take note about that. So which means we shall have something like this. Already the work done is there, which is 159 kilo, but remember I said 159 kilo is same as 159,000. So we're going to use 159,000 over the time that we are given. This time that we are given here, let me just put it aside. We are given our time as 35. Oh, it's 5 minutes. We are given our time as 5 minutes, but we are supposed to convert this to seconds. So how do you convert? To seconds, you're going to multiply 5 times 60, because in a minute we've got 60 seconds. So in order for this to be in seconds, you have to multiply. So which means you're going to obtain 300 seconds. So you're going to divide by 300. So this is what you're going to have, which is 530 from your calculator. You're going to obtain 530. Remember, this is power, guys, which is measured in in watts. Power is measured in watts. So the watts there, you just write it as what? As a W. It's fine like that. So as you can see, guys, these are very, very simple questions. They ask these different ways and formats. Then we are given that a 40 kg object is placed on an inclined plane forming an angle of 20 degrees with the horizontal. Calculate the force required to pull the object up the incline. All right, we need the force that is required. Take note here, guys. Calculate the required force to pull the object up the incline. All right, so this is what you're going to have. This is what you're going to have. We know that if we are given an object which is going, let me just represent this, because there's an angle there that we are given in between. So this is going to be 20 degrees there, just showing you what's happening here. 20 degrees, and we've got a mass there of 40 kgs. All right, so this is a mass here of 40 kgs. Okay, now we are given that this object is being placed on an incline which is forming an angle of 20 degrees. Calculate the force required to pull. As you can see in this case, we are supposed to have a condition where we will be given the force that is opposing, which is the frictional component, which we do not have in this case. So that means we're just having something which is equal to 0. But we can't say this is equal to 0, because every time that we are talking about the frictional component, it's always a friction which is opposing the applied force, which is the force that is giving this object to go up. So that means our F up in this case is going to be the force that is requiring this to go up, which is going to be the vertical component here, because it's parallel. So it's going to give us the vertical component. So we are going to have W sine theta. But where are we having this W now? Remember, you're given the mass. So we can formulate this from W, which is equivalent to mg. So that means I can obtain the W by multiplying mass times the gravitational acceleration, which is mg sine theta. Now we can substitute the mass, that is 40 by 9.8 by sine theta, which is the angle of 20 degrees. All right, I hope is it clear? Or now let me just try and adjust this side. So that's what you're going to have in this case. So using your calculator, actually you can multiply this, which is 134.0718 something like that. This is what you're going to obtain. So at least you can round off this to 3 decimal places if you want, depending with the best degree of accuracy that you'll be given there. So this, I'm going to put this 1 is going to be affected by 8, so it's going to change to 2. But remember, this is the force which is actually measured in newtons. So that is what you're going to have there. The force that is being applied up is the same as the frictional component in this case. That is what is happening. This one is pulling, this one is going down. Remember, for every force that you're going to apply, there's going to be a force that is opposite to that force in the same magnitude that is going to be reacting. So depending with what you are given, provided that it is in equilibrium. Okay, so in this case, these were the conditions actually that what you needed. So as you can see, it's best for you to have a sketch whenever you are working with questions, especially questions to do with calculations. You must have a diagram at least that is going to help you to find the exact thing that you are calculating there. Okay, anyways guys, that's what we had on this question, which is on work, power and efficiency, from the question paper of August 2021 from Memo African Motives. Till we meet again.